This program is presented by University of California Television. Like what you learn? Help others discover UCTV podcasts by leaving a comment or rating for us in iTunes.
So first, we have Jeremy Weiss, who is a senior research specialist in the Department of Geosciences at the University of Arizona, where he works to assess the impacts of climate hazards on natural resources and applies geographic information systems and data visualization to scientific data generation and communication. His research focus include climate-induced vegetation change, past and future, regional climate science and assessment, and climate change and the sea level. So please help me welcome Jeremy Weiss.
Well, thank you, Lisa, and good afternoon, everyone. And I'd especially like to thank Janet and the rest of the organizers for giving me the opportunity to come to Santa Barbara for this really exciting experience. I'm going to go ahead and get started, as after all, this is a lightning talk. If you were to ask me what I spend most of my time reading when it comes to sea level rise, it's really on the physical science behind the factors that change sea level. Yeah, I'm thinking about things that are going to be changing, adding volume to the world's ocean, the input, glaciers, ice caps, as well as the polar ice sheets. I'm also going to be spending time, I also spend a lot of my time reading about the behavior of the polar ice sheets as far as what is really driving their losses. Is it due to simply warming air temperatures and they're melting at the surface, or are some of the ice streams that are discharging at their coasts speeding up and hence adding more volume into the oceans that way? I'm also concerned about reading a lot about the ocean processes that go into this in terms of circulation and density changes. You're really looking at regional scale phenomena. And an example with the circulation would be the Gulf Stream, its behavior in the future under climate change off of the northeast coast of the United States. And in terms of density changes, we're thinking about as the oceans warm and as well as their salinity changes. In addition to that, I'm also thinking ahead in terms of future sea level rise and studying about projections or estimates of what sea level might be. And at present, in the sea level rise science community, there are different ways to go about doing this. We have Earth system models, which are basically, I don't even know the number, how many lines of code of mathematical formulas that are used to describe the physical processes going on around the globe. We have semi-empirical models, which is an approach to looking at the correlation between past global temperature and past sea level rise. We have geological or paleo studies that are using proxies to infer environmental conditions in previous epochs during Earth's history. And we also have physical constraints where, for example, glaciologists will go out and try to estimate how fast some of these changes, for example, with the polar ice sheets, how fast these changes could ultimately be. Now, as Doug was mentioning a little earlier today, I was part of a group that went out and surveyed this literature. And if you were to do that, you'd find a wide range of plausible estimates for sea level rise by the end of the century that range from under 0.5 meter to upwards of 2 meters. And again, this is including all those various approaches that are available to the science community right now and being developed. So we have this tremendous range, really, of uncertainty in terms of what future sea level rise will be at the end of the century. And in the context of this report that I was a co-author on, we took the scenario approach to try to grab a little extra meaning out of that wide range of uncertainty. And if you remember from Doug's presentation, he had a time series graph where we had 4 scenarios listed. And those scenarios range from the lower end of the estimates up until a high range of the estimates. Now, I wanted to note, in terms of scenarios, when we're thinking about it from a physical science modeling perspective, they do not predict future changes, but describe future potential conditions in a manner that will support decision-making under uncertainty. You're not going to be able to have a scenario for every increment of sea level rise that's plausible at this point. You're going to want to strategically pick a few that you can work with under your own constraints. And it's also important to note that using multiple scenarios encourages the experts and decision makers to consider multiple future conditions and develop multiple response options now that may reduce future vulnerabilities and impacts. So here's a screen grab of our web map application. And in contrast to Doug's, which is geared towards an audience of decision makers and coastal planners and people who are more involved in those lines of work, ours was really geared towards general public consumption. It's an intuitive, simplified interface in which, for example, when it's first opened, the 1 meter elevations that are less than or equal to 1 meter are initially highlighted. And the reason for doing that is that we wanted to link what we know about science, the sea level rise science that's out there today, and 1 meter, of course, being in the center of that range of plausible future amounts. We wanted to link that science with what people experience, that is, the places on the map that they inhabit and that they recreate in. But as you scroll down in our table of contents, as far as looking at the different elevation levels, you'll notice that it goes upwards from 2 to 6 meters. And so why did we do that? I mean, above 2 meters really isn't within the plausible range of sea level rise scenarios for the year 2100. The reason is this. By 2100, the current projections are that the global temperature will be about 8 degrees Fahrenheit above current day. And that's going to be enough to essentially lock in 4 to 6 meters of sea level rise over subsequent centuries. And how do we know this? Some of the paleo studies of previous epochs in Earth's history have showed us that when Earth's temperatures are at this level, that's the height of the sea. So real quickly, as far as the proliferation of interactive visioning tools for sea level rise, and some initial thoughts on that for me, are that part of it has to do with the now widely accessible and functional and understandable mapping tools. The technology is there to show these data. But also, from my point of view, it's the development and the maturation of sea level rise science that has happened very quickly, especially in the last 10 years. In terms of differences among tools, in terms of information, graphics, and user interface, one of the key things for me is the intended audience. And I was one of the co-authors on the 7 minutes already. You're kidding me? Okay. In any case, we had a relatively complicated web map interface compared to ours, and the user made this comment. Thanks, it now takes me 20 minutes to look for something when it used to just take 2. Okay, so knowing your audience is key here. And finally, the effectiveness in communicating science, climate change science. I think I'll leave that more for the panel discussion at this time since I'm out of time. But thank you.
The next speaker is Marco Pellian, who is a colleague of mine. You might want to come down since this is a very short, it's a lightning kind of. And I'm always really excited to hear what he has to say. Oh. So it's going to be interesting to see what he has to say here today. He's a professor in the Art and the Media Art Technology program, and he's also a co-director of the UC Institute of Research in the Arts here at UCSB, or campus-wide, or no, system-wide, sorry. He founded the technology branch of Project Atoll, a GPS-based participatory network mapping project, and he's also he's currently coordinating the Arctic Perspective Initiative Art Science Tactical Media Project. He has received many prizes for his work, including the 2000 Golden Nika at Ars Electronica and the UNESCO Digital Media Prize in 2004.
Thank you, Lisa. I was under the impression that, the Pecha it said Pecha Kucha style, not Pecha Kucha. So I'll try to plow through my slides at a very high speed. Okay. I recycled a little bit a presentation that I did at a conference in Australia just recently, but it's sort of very, very appropriate. It's not recycled. There's much more stuff in this one, in a different aspect. As Lisa said, we are artists. We are also engineers. Sometimes we build our own tools, and I guess my presentation will be a lot about building these tools. My background is in art, but I also have been working with radio and the electromagnetic spectrum, and from my childhood on, I was 10 years old when I was part of a radio amateur club. I come from Slovenia. And we had something called the Technical Culture Societies in Socialism. And one of my colleagues cracked the sort of encoding for the first Meteosat satellite. The European satellite, and we built these Meteosat receivers, and there was 4 of us with huge 10-foot dishes, and every morning we would get the fresh picture of Europe from the point of view of the equator, and that's sort of my background. This is another picture, though. This is MODIS, one of my favorite instruments, and I've been since working a lot with satellite data. My work has really been concentrated. Part of my work, not all of it, to the Earth's poles, the Antarctic and the Arctic. First the Antarctic and later the Arctic. And we've done a lot of work in the Arctic. The project is called Arctic Perspective initiative, and it has a website, so you guys can look at it later. Mapping, this is like one of the comprehensive maps of the Arctic that we created for a project with a lot of different layers. It's a physical, it's not a digital map. It was like a huge wall piece. But I also, talking about tools, we built this project with a lot of collaborators that ran from 1997 to 2007. It was called Macrolab. And its sole and only and very complex purpose was to basically concentrate on 3 global dynamic systems: weather and climate, migrations in all kinds of ways, and telecommunications. And the idea behind Macrolab was that basically if you would understand how these 3 systems interact, you would be able to build an Earth system model that is way beyond what we have today, because it would encompass, of course, also all the economical data and all of the sort of world's telecommunications and everything that is in them. So that's why it resides in art, because science cannot think this way. You would need probably 10 Macrolab universities devoted to this project. But utopia is sort of where we are very comfortable operating as artists, and that's why we build Macrolab. This is a self-portrait of Macrolab from a satellite. You can see it there on the island, and this is the actual picture of it. But in terms of tools, we built also weather stations, a lot of them, before this became quite a popular sort of hobby. This is one of the larger ones that we built, and it's still operating in Ronin Modland in Antarctica. This is my colleague Adam Hyde, who is peeking out of the laboratory there. This is a project that was sort of supposed to be finished in 2007, as Macrolab is supposed to be this structure and move around the Antarctic. But as the engagement with the Arctic has really started, also at the same time, I discovered that in the Arctic, of course, there are a lot of people live in the Arctic, much more than we are used to think and believe. And not only that, but that these cultures of course, have a history of resilience that is almost uncomparable to our very, very comfortable sort of Western or Eurocentric point of view of the world. And there's a lot of cultures in the Arctic. This is where people reside and who they are, according to anthropologists. And one of the things that we really discovered in the Arctic is, of course, that there is a large amount of knowledge, which science calls local and traditional knowledge, LTK, compared to scientific knowledge that is sort of present locally. Of course, local and traditional knowledge we have everywhere. We have it here. We have the Chumash knowledge, and all around the world where there's actually native cultures that have a very, very strong connection to the land. The Arctic peoples, and specifically, I worked mostly with my colleagues with the Inuit, mostly, and Sami a little bit. Have a very, very strong connection to technology. And that's where sort of our worlds came together. We as artists / engineers building our own tools, and the Inuit actually working and building their own tools and being early adopters of technology as soon as it comes. So that, even in the remotest parts of the Arctic, just a sliver beyond sort of where you could actually see geostationary orbit, we set up our own hacked satellite connections, build up labs, temporary labs to work in, and operated our unmanned aerial vehicle. That was also a project that came out of the Macro Lab from 2007, where we were in the lab. It's artists and scientists, 80% artists and some scientists and some engineers. And there was always this idea, we are limited with our range of our sensors and so on. And we started thinking, well, let's build a robotic system. Yeah, I have 6:33 actually. Let's build a robotic system that we will be able to sort of map areas around the lab further. And 5 years later, and a lot of headaches and so on, we built this Brahmor unmanned aerial vehicle, with which we can create, instant orthophoto maps like these, which are simple mosaics. And we worked also with scientists. This is Danube Delta, for example, bird counting project. And we can create nice digital surface models with our system without LiDAR. And with point cloud technology and with some ground control points, we can achieve a precision of 5 centimeters. This is for the NOAA colleague here. So with some Russian software, actually. So we worked in the Arctic. I take my students there. I just did this fall. And these are just some photos from there. And these are our maps when we work with the Sami. We can put all kinds of sensors, but we also sort of bring this data to the people and have lectures about that and so on. And my 7 minutes are gone, but we also are building a satellite at the moment. Here it is. The critical design review for this was just finished. It's with the University of Toronto. And this is my remote sensing sort of component of my talk, which means that I won't be able to show it to you. But it's flooding maps using all kinds of data from different kinds of platforms that I worked on, really more on the scientific level with my colleagues from Slovenia. And that's about it. Thank you.
So next we have Bruce Caron. Is that how I pronounce your name? Is the founder and executive director of the Media Research Institute here in Santa Barbara. He's trained in social anthropology and cultural urban geography, and has taught in the US and Japan, and served as an elected member of the National Science Digital Library Policy Committee. He's leading the lightblueline.org public awareness action in Santa Barbara, getting back to the question earlier, and is a principal investigator on an NSA-funded project. And please help me welcome Bruce.
Oh, wait a second. Is this yours? You want?
Yeah.
It's mine now. So.
You should use it because card clock is fast.
All right, let me get queued up here. Oh, play. Just play. That works. All right, so today I'm going to talk about the sea level rise visualization public art project that a group of us tried to do several years ago in Santa Barbara. The project was called the Light Blue Line, and it was an attempt to paint the future impacts of climate change on the streets of the city. Does that work? Okay, cool. I want to introduce some of the issues of uncovering a specific type of local geographical knowledge, and these issues range from the choice of 7 meters to the outrage and blowback from local real estate professionals and climate change deniers over any public discussion about localized climate change vulnerability. Now, the goal of the Light Blue Line was to take a moment from the global future and concretize this as a feature in the local present. We were asking the city to imagine a future where the sea had risen 7 meters. We'd hoped that this imagination would start conversations and spark learning moments about anthropogenic climate change. Let's work together to keep the waterfront down at the beach, we shouted out at the city. Now, what we heard back as an echo was unexpected. Screw that. We're all here to make money. Despite his public ecological narcissism, Santa Barbara turned out to be just another Fresno by the sea. Now, the first question everyone asked is, why 7 meters, right? Why 7 meters? 7 meters was chosen for a simple reason. It represents the amount of sea level rise currently captured in the Greenland ice sheet. Now, starting with a knowable fact gave us a discrete story to tell about a very non-discrete and non-linear process. 7 meters of sea level rise is just one future moment. It's a moment that will predictably occur sometime after the planet's climate system hits a certain tipping point. And this particular tipping point results in the complete and irreversible melting of the ice sheet on Greenland. Other ice sheets have similar tipping points, and once they're reached, the ice sheet will melt completely. For those of you who are over 40, you can say this is a defrost switch, on parts of the climate system. Now, much of what we cherish about Santa Barbara today would be destroyed and forgotten long before the seas arrive at 7 meters. The beaches and the airport would have been the first to go. The downtown below Ortega Street would be completely submerged. The only road in and out of Santa Barbara would be Highway 154. Now, there's a saying I think is particularly true here on the West Coast. 500 miles is a long distance in Europe, and 500 years is a long time in the U.S. We found it remarkably difficult to get people to care much about the longer-term future impacts of global climate change. It's like asking people to watch a zombie movie where the threatening zombie horde can only shuffle along at 1 inch an hour. There is, after all, no shortage of more immediate bad news. The mental buffer we use to calibrate and respond to the danger and risk is kept absolutely full by a daily diet of fear from television and the internet. That was exactly why the Light Blue Line team decided to put paint on the street. We wanted to reach people who'd never gone to Earth Day. For the majority of Santa Barbarians, Earth Day has about the same impact as a Renaissance fair or a homeopathy convention. We figured that painting a contour across the entire city would force almost everyone to drive across this line in their Escalade several times a month for the next 5 years. And their kids, at least, might notice this line on the street and ask their parents what it represents, and then school them on what it really means. Now, in many ways, Santa Barbara is not simply Fresno by the sea. We had excellent support from the City Council and access to climate scientists and GIS experts. We'd hoped for Santa Barbara to be the vanguard of a global climate change public art movement. We envisioned light blue lines across coastal cities around the planet. Now, some of these lines have happened, and more are probably going to happen. But at that time, we faced the brunt of a reaction that had more resources and a lot more room to hedge the truth than we did. Our story about the light blue line was anchored in the best science we could find at the time. And our project was never designed to cost more than the price of the paint and the website. So the day after the city council vote, we discovered that the Santa Barbara News Press would pick our project to show how anti-business and eco-crazy the city council was. Now, their editorial position was clear. Climate change is a fraud. The only thing the light blue line would do is scare people and lower property values. And the city council should focus on disappearing the homeless on State Street instead of drawing silly lines on the public pavement and private property. Now, the news press has and had no science or education writers in-house. They had failed to even have a reporter at the Light Blue Line Decision Council meeting. They also failed to attend any of the Public Art Committee meetings or votes that we went through. But for the next several weeks, they created daily stories and devoted their editorial pages to one topic: stopping the light blue line. Now, we were still 3 months away from the November City Council election, when all of the challenger candidates, who would normally be bashing one another, signed on as a bloc to oppose the light blue line as a prime example of civic foolishness and government waste. Now, looking back, some of the narrative threads from their editorial pages are illuminating. Someone asked, what's next? What's next, they said. Lines for floods or earthquakes? Lines for wildfire threats? How much information should a home buyer be allowed to know? Just how many lines could a community handle, given that it treats its real estate like an ATM? The endgame for Light Blue Line occurred when a deep-pocket real estate tycoon named Jerry Beaver ponied up the funds for a protracted legal challenge. It was clear that the line would not be painted soon, and that delay would only strengthen climate denier candidates for city council. So we were asked to withdraw the proposal, and after some internal deliberation, we agreed. A while later, I ran into Dave Davis, who runs the Community Environmental Council. Dave, I said, we failed. Failed, he said. Hell, you got more publicity for climate change than anyone could have ever imagined. Now, that's the story of the light blue line. And maybe it's not over yet. There are rumors that liners are lurking and plotting, and new liners getting ready to paint something. Windy and the Beaver better watch out, because there are any number of people ready to mark the city's vulnerability to climate change. So what do you say? Is it too late to work together to help keep the waterfront down at the beach? Thank you.
And so the last speaker is James Frew here from, where are we at there? Also here from UCSB. James Frew is a professor in the Brent School of Environmental Science and Management here at UCSB, and a principal investigator in UCSB's Institute for Computational Earth System Science. He's trained as a geographer. He has worked in remote sensing, image processing, software architecture, massive distributed data systems, and digital libraries. He currently leads the Earth System Science Server Project and is president of the Federation of Earth Science Information Partners. Please help me welcome James.
There was a, am I live? There was a former president of the Earth Science Information Partners there glowering at me that I am no longer the president of the Earth Science Information Partners. That's okay. Let's see, what have I got here? So I sat down and did some figuring, and as an academic, I figured in 6 minutes I could probably say one thing. So I only have 2 slides. Right? You got one there? Let's make that big. Okay, so one of the things Bruce didn't mention about the light blue line activity was that one of the ways that we tried to get it in people's faces was by attending things like Earth Day and homeopathy conventions and stuff like that. And we had booths, like everybody else does there, and hanging from the sides of the booths were these posters that we made out of these maps that we created showing the 7-meter inundation contour. And any of you ever, did anybody see any of these back when it was live? Anybody here that remembers any of that?
Yes.
What? Yes. What? Okay.
I didn't, and I'm surprised that I missed it, yeah.
Well, I mean, there were a lot of booths there. You might have got hung up at the water filters or something. But anyway, so I was actually kind of proud of this map, especially since my grad student was the one that actually did the design on it, and he has way better graphical sense than I do. But I was a little bit concerned as I stood next to this map and watched the reaction of people when they came up and looked at it. And those reactions basically fell into 3 categories. The first category was, this is all BS and you guys are just feeding us a big line about something that doesn't exist and whack, whack, whack. And I expected that. Okay, that's fine. But the other reaction was looking at the map and saying, let's see, uh-oh, I live here. My house is going to be flooded. I live here. I'm okay. Okay? Or for the few, I live right near the line, but just on the right side, I've got a beach house. Yeah. Okay? And, I understood where they were coming from because my house, while not on this map, is comfortably above the line, so I understood the relief at not seeing one's house drawn at the bottom of a lake. But really what that did is that made me think about what a mixed message a line sends, okay? Because when you draw a line, you're making a distinction that says on this side of the line one thing, on this side of the line the other thing. And here, the message is quite plain. On one side of the line, you're swimming. On the other side of the line, you're not. And that really undersells what's going on here. Very few people picked up on, as Bruce pointed out, that nobody lives on Highway 101, unless you're. Nobody lives on the railroad track, and yet the fact that the railroad track and the highway are flooded here is way more consequential, pardon me for saying so, than that your house is flooded, okay? I mean, that's the end of Santa Barbara as we know it if our transportation network is interrupted like that. But, that message doesn't come through very clearly here. The message that my house is underwater or not comes through very clearly in a map like this, but the larger community message of what happens doesn't come through very well. And I take as much responsibility for this as anybody, but it was something that wasn't really clear to me until I heard everybody responding to this map as an individual, okay? That it's difficult to respond to something like this from a community perspective if there's something on it that also affects you personally, perhaps in a different way than it affects the whole community. So kind of riffing on some of the stuff Bruce said, now I'll show my other slide. Okay, I lied. My other slide's a program. So there's the line drawn on Google Earth, which isn't terribly edifying. But let's see what happens if we draw this as a set of inundations. Okay, turn that off. All right. So, let's slide that over a bit. Let's turn the line off. We have a little bit of a registration error. There we go. Come on, go away. So here, if we zoom out a bit, you can get a real sense for what's going to happen to would happen to our community if we actually really did have 7 meters of sea level rise. Now, that's a community-ending event. All right, no airport. One of the exercises I give to my GIS class is take the inundation information for downtown Santa Barbara, and this is, I think, Doug, you were talking about this, like one of the things you look at is property values. We take a parcel map that the city gives us that shows how much every parcel's worth. Used to show who owned it, too, which was kind of interesting, but they don't release that information anymore. And we flood it, and we sum up the value of the parcels. So just for the 7 meters, just for this amount of sea level rise, what do you think the value of the property is that's flooded?
Just the assessed value of the property is about $3.5 billion. Okay, $3.5 billion of value just evaporated by this. And that's the assessed value. And if you're a Californian, you know what a bunch of hooey assessed value is, okay? You know, the actual value is a heck of a lot more than that. So, and again, so that's $3.5 billion of property value sunk, and that's noise compared to the rest of what's going on here. As Bruce pointed out, the only way out of town's over 154. Santa Barbara becomes an island. So you go, okay, well, you know, federal government, come in and save us. You know, if something like this happens, they're going to be a lot busier with New York, Los Angeles, San Francisco, Texas, you name it, okay? So an event like this has consequences that are really difficult to imagine. And I think we need help in figuring out how to imagine those consequences. I'm not going to show you a fancy animation of something like that because, you know, I don't know. We've now reached the edge of my graphical skills, all right? So I wouldn't inflict anything else on you. But, you know, I do know that there are stories to be told here about what this means to a community, not just what it means to a particular person standing at a particular elevation, okay? With all due respect to Doug's example of the courthouse, yeah, those guys planned really well, but I don't think that, custom house, I don't think that custom house is going to be terribly useful if it's surrounded by 2 feet of water, okay? I mean, not to say that people won't wade through the 2 feet of water to go see a cool old building that happens not to be flooded, okay? But I do think that there's a bigger, more connected story to be, am I done? More connected story to be told there. So I would love to start a conversation about that and hear people's ideas on how we tell the bigger story here, of the knock-on and the interconnected effects that come from sea level rise. So thanks.
Yeah, I would first like you guys to, now when you heard each other's talks and they were really interestingly interrelated and a great selection of people, I would say. So it would be interesting to hear if you have something like the stuff that you didn't have time to say because it was very short, and like maybe also in the light of what the other people were saying, if there's something first we would like to kind of just have a little bit more time for each one of you before going on with questions.
I want to ask Mark, I mean, the Arctic and the Antarctic are the first places where the flush of global warming happened. So,
yeah, that's, I mean, what was the question?
So what are your? I mean, they're like the canaries in the coal mine. So what?
Yeah, that was the reason why the interest of MacroLab as a project looked at the Arctic and Antarctic. In the early 90s, when the project was started, climate change was not a very big topic. It was very difficult even to talk to people, especially from the sort of art science point of view about it. And of course now it's a different story. And this data, a lot of the data that we have and the sort of participatory, GIS models were not available. So it was a very different way to collect information about the global sea rise in the beginning of 90s, pre-internet as it is now. So I'm pre-public internet. But for me, it was clear just by reading literature that that's the two regions that are of interest. Antarctic was also interesting politically for me because it's the only transnational sort of territory on the planet besides the seas, right? So it's sort of the only real potential utopia, and it looks, well, there's no really cultures there except the culture of science and now tourism and so on. But in terms of just, as a quick reply to what you just asked as a question, and my own experience, because the last 3 minutes of my talk were devoted to this participatory project that we are working on in the Arctic called Sinuni, the landing Silamilu Nunamilu Nipiruti. It's in Inuktitut. It means we called it a landing climate recording device, and it's a set of meshed sensor networks that people would use while they go out on the land and so on. They collect basic environmental information, atmospheric and so on. But for example, we also are now implementing like a methane sensor and things like that, so that you would start having this rather high resolution, multi-data points, complex maps, and the data would be owned by the local people and shared with the scientific community and so on. So it's a very different kind of approach when the people really live connected to the land and so on. And I think the problem of Santa Barbara, and when people see this map, is exactly this, you know, in an Inuit community, it's a community, you know, everybody is involved with the land and they understand that they are very dependent on it on multiple levels. Whereas in our societal structure, it's, you know, okay, I live here, if you live there, I don't care, you know. I will live probably for 40 more years, you know, and that's it. And it's really a different kind of sort of worldview.
It's depressing, like that we don't have this sense that getting even the railway out, that would, or the airport going out, that we don't really sense immediately that would change our lives. That we were first things about our house. It is kind of interesting. But of course, we also know that we are dependent on at least the infrastructure, but maybe not on the environment the way they do. But
yeah,
it's still,
until you experience lack of infrastructure, you don't know what it means.
Yeah.
Right. So that's, you know.
Anyone else wants to add to the?
Yeah, just to carry on with that particular concept, you know, when James was talking about, you know, individuals coming up to him after reading the map and saying, I'm on this side of the line or I'm on that side of the line, and all the inherent problems there. And then going into talking about it more on a community scale. It struck me that, is that the more appropriate human scale then, to think about the impacts, perhaps, of these, of sea level rise? Potentially, or do you need both the individual and the community scales when you start to think of these impacts?
Well, I think that one of the things that is bedeviling about the problem of sea level rise is that it is inherently a multi-generational problem. You know, we're not, knock on wood, that's close enough. You know, hopefully we won't get a catastrophic event that triggers, you know, a significant amount of sea level rise, although that's not impossible. But, you know, so you have to think about it in terms of a multi-generational type of problem. And, you know, our best connection to that is through our families and our community. And so, you know, having a community aspect to it wired in from the beginning seems to me to be one way to get people to appreciate it, you know, without having to go beyond, okay, well, at least my house isn't going to get flooded, you know, so I'm okay. I was especially like when Doug was showing the way that you could flick in things like community, there was a sort of a generic, you know, social impact layer or something like that. You know, it seems to me that if we had these maps such that if you dialed in a particular impact of any kind, you know, whether it's sea level rise or, you know, additional toxins in the water or whatever, that, you know, in addition to the localized impacts of it, you'd have a way of seeing some of the broader impacts. Like, for example, let me put this up again. Where is it? There's the, come back. I used to know how to work a computer. There, okay. So imagine that, you know, say if one, for this particular scenario, which, like I say, again, 101 being flooded is a big deal, but a lot of things will be worse. Imagine if one of the things that got dialed in was, oh, you're going to have to reroute the highway. The highway is going to have to go up here, okay? And so to build that highway is going to cost about that much. And you could do that, you know, really, you know, could make a really back of the envelope calculation just by saying, well, the highway can't be inundated and it costs, you know, however many $1 million a mile to build a highway. And then, oh, and we got to condemn the property, so it costs about that much. And you can come up with a corrected within an order of magnitude estimate about how much this is going to cost to rebuild this road. That's assuming that there's stuff off the map here that you can still drive to. You know, but no, and you know, so you can have those kinds of impacts factored in. It's still a local impact. You go, oops, you know, instead of the light blue line, we have a light orange line, which is all the little flags on the Caltrans survey stakes that show where the highway's going to go. So, you know, or, you know, saying, oh, by the way, the airport just flooded. Your options for flying are now out of the airport in Santa Ynez, not very big, and you got to take a bus. So, you know, your commute just turned into this if you're one of these people that commutes out of here by plane. So there's, you know, it seems to me that you could dial some of those things in to some of these tools in a way that would make these community impacts more visible. Doug had a comment.
Well, yeah.
Oh, did I jump the gun? I'm sorry.
No, just he needs a microphone.
Yeah.
So for the.
Now it's gone, sorry. Okay, so I was thinking about that because then you can do it for your community, but if you start talking about the impacts, you're saying, oh, we'll have to use this airport. Then you have to even go farther out because the other communities are all impacted. So you can't just send people to this place because that's going to be impacted too. It becomes a huge cascading kind of thing. You know, it's a real
I'm just wondering here, like that's kind of not such an exciting thing to think. It could be. I think it could be interesting to think about as a movie kind of thing, imagining all these different effects. But right now, the movies that we see, which I love to watch, like the Day After Tomorrow and so on, where you see the water coming into New York City and that kind of stuff. It's just very. I mean, it's kind of sublime with these major catastrophes, seeing how it's just nature overtakes our structures, kind of, and that's just, it's amazing to see. So for me, when I started to look at some other site where I could, you know, do this visualization, and I saw that my house, which is somewhat up towards the Mesa, would become a waterfront house, and that was the first I was scared about the tsunamis. That's why I went to the site, and then I realized it was because it was a tsunami warning. Then I realized I'm safe for the tsunamis, and then I started to look at it and realize, okay, the waterfront house, and then where should I go and get my groceries? I realized I will be on the same island as Lazy Acres, exactly. I would be on the Lazy Acres island, and that's okay. Like, it's a good story. I mean, and then in my mind, there's this
48 hours.
Yeah, exactly. This movie started to play out in my head, was this really amazing water landscape, and we meet up at Lazy Acres, and but it's just weird because these movies, it has this kind of beauty, like these images that you showed also with the beachfront in Santa Barbara. They have this they look amazing. The water on top of the landscape, it just, with the houses and everything, it's just very sublime, actually. So it's weird. It makes it difficult to imagine all these other things because it has such a strong draw, just visually and artistically or poetically. I think, you know, how when we see the idea of having whole cities being submerged by water when they make dams and so on, it's just something very dramatic and easy to get a hold of us. So I don't know how to get this other stuff equally strong.
Except when they build a dam, usually the first thing they do is they slick the city. So what they're covering is a bunch of foundations.
Yeah.
They're not
they don't.
Yeah,
but
I mean,
in the
the
movies, they show
gone,
it as with the church tower sticking up and so on. Of course, that's not really happening, but yeah.
Yeah, so one thing about the 7 meter is, you know, we talk about sea level over the next 100 years, and that we're talking 6 feet. Yeah. This is Greenland melts, and that is a minimum of, what, 500 or 1,000 years just for the physics of melting that much ice. So it seems like people respond to, well, this could happen in my lifetime, or, you know, my house. It's like, well, there isn't a chance in hell that any of our houses are going to be here at the point that map actually becomes reality, which I think it probably will. So does that then, you know, how do people respond to that, and is that then a useful image for why you should worry, or is that so cataclysmic and yet so impossible within a lifespan that it's actually not a very functional image? What do you think about those dynamics?
We actually used it just to get a sense of the sort of the larger scale of what's happening in the longer human future. Like I say, 500 years seems like a long time for us, but if you're in, you know, parts of Europe, your neighborhood has, they're putting up plaques for the 500 years that their house has been there, kind of thing. So, so it's like Colbert says, we've already lived 500 years. Well, wait a minute, there's a, so we can imagine a 500 years on the other side of it. We can't do that here so much because our house was built in 1957 or whatever. So,
or 73 after the last one burned down.
So what I'm saying is that this was a starting point. Okay, we're trying to start with a story that it opens up sort of the larger imagination, and then let's say, well, okay, so in the next 50 years, if it goes up, half a meter, that's going to take out, part of the airport. It's going to take out the water purification. It's going to perhaps affect the aquifers. And so we're going to be, and so this was sort of like, the slap in the face for people. But you're right. As soon as people say, well, how long is this going to take? And that's why the news press did this thing where it's going to be 10 years. I said, and I said, well, no, of course I remember the conversation with the intern, right? Which I said, well, this is like a 500-year process, but we really only have a decade window to address to act, right? And so the next day you get it, there's this, oh, that's going to be in 10 years, right? That's why I was getting death threats, right? So.
Yeah, I'm wrestling with the same type of thought that you just expressed as I'm sitting up here now and over the past number of years is the immediacy of the issue. Is it there or is it not there for so many people? And it's been tough from my experience, or at least challenging, to try to communicate some of these more longer range impacts that the science is slowly piecing together as far as consequences of the emissions of so much greenhouse gas, so many greenhouse gases. It's been really challenging to try to structure the conversation, or in the case of press release, the quotes, such that you're getting the right message across in terms of what meaning you're exactly trying to convey. And at least in the case of thinking about the end of the century, people born today might actually be experiencing that. So we're actually within, theoretically anyways, a generation's reach of some of these impacts that we're thinking about projecting. And getting further into the subsequent centuries, it's a tough task to communicate that to even an informed audience. But needless to say, it still is an important issue. I mean, it's not as though everything's going to stop in 2100 either. We have to think about the longevity of some of these issues, and with the immediacy of so many other things going on in the world, it's very difficult. And I think that once you start to think of, how can we figure this out in a more immediate time scale, more short-term type things, it's the events that we're starting to experience. And being on that group that put together the multi-agency report on sea level rise scenarios, I was reading up on some of the literature before going to our initial meeting and workshop, and I was struck by how even just nominal amounts of sea level rise, talking about tens of centimeters, something equivalent to what we've already had in many areas over the past 100 years or so. Just even with nominal amounts of sea level rise, once you get a storm surge come in with a high tide event, suddenly your impacts just go off the charts. And it's really something that in some cases you hadn't experienced yet historically. So, perhaps, in terms of the effectiveness of these things, communicating climate change, it's going to be a tricky balance as far as thinking relatively long term, and then, with the stuff, that Doug's trying to incorporate in his tool with storm surge and such to get more on the short term and more on the planning horizon.
I'm curious about whether or not the survival of non-human communities and systems, non-human life, ever enters into these figurations. I mean, I haven't really seen a lot on that, but I'm not, I haven't studied this or researched it to a great deal, but we've talked a little bit about which kinds of communities are given attention and which are not. What about non-human communities and habitats that sustain us via other life that sustains us?
Well, in terms of overall climate change, yeah, there are lots of people studying how fast the trees migrate as opposed to the temperatures that they require, and how the forest can't keep up with it in lots of places. And then your tool has also marshland, whether the marshland is going to be able to move or not. So there is an awareness of this, and people say, there's not going to be any more, fall foliage, maple syrup coming out of Vermont and this and that. And if you live in Vermont, that's kind of horrifying to think that your kids aren't going to.
But I do think that, I've looked at some climate change analysis where you do see the non-human represented, and certainly the question of forest and drought and all these things are part of the larger questions that we're looking at right now. But it does strike me that it's part of the same problem that we were talking about before, where instead of looking at infrastructure, people are looking at their own homes. And one of the infrastructural issues that seems to be so crucial is just larger ecological infrastructures. And I know that, again, in some broader climate change analysis, of course that's important, but with the sea level rise, that would also be a relevant issue. And it doesn't, I don't know, it just hasn't seemed to come up as much as I would expect.
It'll make a nice reef, actually.
Yeah, there you go.
I think that as a culture, humans, clearly we are not wired to be very good at prediction in general, and Western culture in particular, and also because there is a very, very there's a tendency there's no civilizational memory anymore. We are sort of bombarded with data, as we've seen in your slide, on so many levels that it's very, very hard to distinguish a pure signal in this. And that's the nature of the Anthropocene. And I think that's really a much more structural problem. Even to look at the world through capital value of land is sort of ridiculous when we talk about this kind of timescales, right? So hopefully somebody will finally figure out something else than capitalism in 500 years. Or, we will self-destruct as it looks like we're going in that direction pretty successfully. So, and then we'll maybe try to colonize another planet, but maybe it will be too late. So I don't know. I'm not very optimistic. If you look at what happened in the last 2 centuries with humankind, there's enormous progress on one level, but also very, very the potential for annihilation has, again, we are bad at prediction, so I cannot say how much it has risen, but my intuition is that exponentially. So.
And thank all of you.